here. And away we go. And I got some sound. Good. All right. You should be able to log in there now. Hopefully you can. And once you do, just go ahead and join the meeting. We're all set up. Okay. Now, did you get into the meeting? Oh, have you okay. Because I posted the invitation there just a minute or two ago. Are you in the meeting already? Oh, okay. Well, if you are, if you're already in there, you're good. Now, you should be. Make sure that you're in the one. I posted an announcement there that says new invitation March 29, 2018. That's the one that you'll want to use. Okay, and you're in. Good. Okay, because I'm looking to see. I've just got one participant, so I'm not seeing you in there yet. So.
Should I join even though I'm here?
Yeah. Yes. Yeah. You need to, so you can see the screen because I can't project up here for you. Yeah, I'm very sorry about that. At least you can hear me, and then it'll record. So, all right. I assume. Yep. Okay. Good. Okay. Now I'm going to go down to the modules, and I should hear a sound when you join. And if something happens, it's recording. So, yeah, there you are. Right? Yeah, very good. Okay, excellent. Thank you so much. Okay, now I'm going to go ahead and get us rolling here. So sorry about all this. It's been a little bit crazy. Anyway, let's go down to we're in the modules section of Canvas. Okay, and we're just going to do some quick kind of homeworks, or not homework, but housekeeping stuff. And we're at the 29th. Now, the 8 and 9, no, I'm sorry, 7, 8, and 9 should have been uploaded already. It was due today, and we've done those databases already, okay? So that would be, you should have had that done. Now, I also have some resources over here on, again, uses of databases in different ways, and how we can use them to solve different types of problems. Now, one of the things that's important, and I talked about this some last week, okay, was the uploads for Lunch's database 10, 11, and 12. And I have this file here, which everybody can download, okay, and use it to upload for those 3 chapters, okay? So you'll want to download that database and then upload it for 10, 11, and 12. And 10, 11, and 12 are due the week of the 12th of April. But you'll want to go ahead and have those uploaded because we're going to push on through to chapter 13. Okay, and again, we did some work with these last week, and I'm fine with that. Or alternatively, and there's always going to be somebody who's going to need the alternatively, we can go into let's see, go to the files. And I have files over here, and you're going to find remnants of different Lunch's databases that I've worked on. And let's see, you'll see something like maybe you might see a 12 or 13. Some of these you're not going to see because I've got them hidden. Let me go down here and take a look. Here's an 8 and 9, and I'm going to publish that so everybody can see it. Okay, there's a Lunch's, in fact, there's a Lunch's 8, 9, 10 for all intents and purposes. Let's see if I can find a 12. And if not, yeah. Here is a 10. And these will be shown up as I publish them. Okay. And an 11. Okay. And then there's 12. Okay. And let's see. So you have a 10, 11, and 12 opened in the files area. You also have the file I loaded up for everybody for you over in the modules area. So we should be good to go, because I want to move us on to chapter 13. Okay. And we're going to work with that, because chapter 13, we start to work with joins. Hi, glad to see you. Hey, glad to see all of you. Hey, thank you so much. We've had some technical issues, but we're here. And I had the other room, everybody was just like, I'm hesitant to say it was hot as hell, because I've never been there. Although my funeral director said I'm probably going to need a heat shield. So that being said, we're going to look at Lunch's Database 13, because I want to move us into, I think we've done enough with running queries and things like that and table design. I want to move us into doing joins. Okay. This is where we can really start to do some powerful stuff and begin to tie tables together. And I got a question here. All right, glad to see you too. Good. Okie dokie. Now let's go back over to the modules area. All right. And I just want to make sure everybody's on top of what we've got to do, what's ahead of us. All righty. So again, Lunch's Database 7 is done. Due, pardon me, 8 is due, which we've already done it. 9 is due. And then I have some resources here as I do each week to try to show you some practical example of the application of these, okay? Now, we're going to start working with joins, all right? And I wanted to go over to the files section. Okay. And we want to go over to the files, the Patrick files. Why am I doing this? I can do a search and get it back much quicker. Okay. And here are the Patrick materials, the zip file. So we're going to download it. Okay. And we're going to go ahead and take SQL Fun, and we're going to throw SQL Fun out on the desktop. Now, SQL Fun is basically what I would call, because of its size, it's more like a data mart, okay? So, but we're going to come in and pull stuff from it. Now, here, of course, is the access code, okay, for each of the chapters. I've got that out there already. And so we're ready to work on 13. Now, chapter 13 starts over at page 473, and it starts us with the simplest of joins, and those are inner joins. Now, when we did BISS 1123, you remember we had 6 access cases, and we did, I think at one of those cases we did a join, okay? There are 3 types of joins, all right? And I have some resources over there that talk about them. The first is what we call an inner join, and that is where we link 2 tables on the basis of their intersection. Okay, so everything has to match. That's what we call an inner join. A right join is when we get everything for we get everything for the data set or table on the right, okay? And then we also get where they intersect, where the two sets intersect. Then a left join is where I get everything out of the table or data set on the left, and then everywhere where the two tables intersect. And there are different strategies involved with them, and I have some resources there, and he does a good job. And as we work through these chapters, this is where we can begin to really get the benefit, because we're not just pulling data, we're pulling data from we're linking and working with tables. And so I wanted to move us on to that. Now, when you go out to work, all right, you're gonna have a lot of visual cues, et cetera, that will already have this stuff underlying, and that you'll be able to work with. You'll just click on stuff, it'll be drag and drop. Most of these commercial products are very, very, very intuitive and designed to be that way. But again, Access is kind of the baby database, the best one to learn on, and it gives us a good sense of what's in there. So he starts over on page 476, okay, and then the textbook. You ought to have the textbook out. If you don't have it out, take a look and follow on. And he has 4 tables, table A, B, C, and D, okay? And then he uses, okay, a query that promotes an inner join, where we get a result table from all of those 4 tables. And that's at step 1, he tells us on 476, and step 2. So we extract the data. Now, if you look at step 1 and step 2, what you're going to see is that when we do a query, especially when we start to do joins, we really do what we call an extractive process, and that is I start with a whole bunch of data or a whole bunch of records, and I really through the join call down to a much, much smaller data set. And the reason we use the terms data mining is because it's very much like that. You know, when material substances are mined, okay, they're usually embedded in some other mineral or in the earth. And so what happens is you know, you go get a chunk of it where you know it's at, and like copper, I probably is the one I'm most familiar with, and you literally go in and scrape off the side of a hill. There's copper in there, and they have a process to extract the copper out of all of that massive material. It's the same story that happens when we do data mining, okay? Now, what he says is he starts here, he says over on page 477, the best approach is to join 2 tables at a time, okay? And that's a fairly iterative process. And if you look at 478, you're going to see this process. Now, you're not going to be database administrators, but you are going to be users of data. And, you know, you'll be able to tell as you work through your dashboards and when you're at work working on your machine, whatever client you're using or product, you'll have a good sense of what tables you're able to access and the ones that you're not. And so as you look here at page 478, excuse me, you see him take A and B and combine them to AB. Then you take AB and combine to ABC. Then you take ABC and combine to D, and ABCD, and that gives you, notice, a very tiny result set. Now, this is possible, and this iterative step of combining 2 tables is possible. We can do thousands of tables in a split second because of high-speed computing, because of the cloud, etc. And so, most large-scale databases string these together. Now, the people who do this the very best, obviously, are Google. Okay, that's why you can Google something and go get millions of hits, results, boom, just like that, because they also have what we would call supervised machine intelligence. That as you go into Chrome, I use Chrome, and you search for stuff, it's going to start to figure out what you're after to it. So as you search, you'll start to see stuff resolve. Okay, in other words, you'll if I put in OK, BU, it'll start to resolve itself and give me some suggestions. Okay, but this is the most powerful thing. Now, the thing that really makes databases the tool that are so useful to us is that the query that walks us through all those steps. We don't alter the data tables. Okay, we just take a picture of what we want. Okay, and it's not too different, say, from an X-ray where or an MRI where you put somebody's body through a chamber and they look at it and they get a picture, but nobody went inside your body. There was nothing invasive that happened. They just took a picture. Okay, and so it's the same principle there, and what gets saved is the query. So he starts with the various types of joins, and he starts with a one-to-one relationship, and that's where we have matching columns. And he's going to start us there with 13.3. So I'm going to open up the 13.3. Okay. And I'm just going to get the code for chapter 13. Let's throw it out here. Okay, and hopefully you've got some good acuity. You can see that. And here's 13.3. Okay, now before we run it, let's talk about what we're seeing. Here we're using, you remember when we did queries and we'd say so-and-so as whatever. Okay, we did a column alias. Here we're using an alias for the table. And to keep this simple, we have a fruit table, okay, and we have a number table, and so we have two tables, okay. And wait a minute, no, yeah, we have A.F fruit, A.F underscore number, B.C underscore number, and B collar. I'm sorry, and you say where are the tables? They're right here. I'm sorry, and right here is from the section, the fruits A. So we're identifying what is table A, and then we're identifying what is table B. Now, if we want to, we match these two, and this is that we use the where clause to match them, and then we use the order clause. We order them by A fruit. Now, what we're working with over here are what we would call a series of slowly changing dimension tables. So let's do this. Let's go ahead and copy the query, okay? And then we're going to go into, all right, and I'm going to click create, and I'm going to go to query design, okay? And then I'm going to close that, and we're going to go down to the SQL view, okay? And paste that in, and I'm going to run it. Now, up at the top of page 480, he gives us the business problem. He wants us to join the fruits table and the color tables with an inner join. Now, I want you to notice something as we look at those tables there on page 480, the middle of it. We've got a beginning table, the fruits, okay? Then we've got a relationship. We have the beginning table number 2, and that's colors. And we want to join them where we have the number for each of them and where they match up, okay? And so we've constructed these two tables, and we want to find anything that's yellow. And the result says, here's what we have. Apples are red. Okay, we have a banana that's yellow, we have a cherry that's red, a grape that's purple, and an orange that's orange. Now, this is very simplistic. However, this might be, for example, let's say you're an original equipment manufacturer, and you've got a table of the original equipment. I don't know, let's say you sell backhoes, okay, or you carry backhoes, whoever sells those things today. And then you'd have another table, okay, of the replacement parts, and you'd link those two up together, and you'd get the result set. So as you can see, and you can see what he's asking us to do. And with the relationship there is when we get the F underscore number equals the C underscore number. Okay. And we've joined the two, and we've joined those two tables, and that's our result set. Now this is a simplistic example, okay? Very simplistic, but it applies within any situation where you've got two tables. And remember, when we talked about tables tend to be taller because you have columns relative to rows in terms of the array. The columns you have fewer columns than you do rows. And so when I'm harvesting data, for example, okay, I'm going to run an inner join. Okay, and let me give you an example. Let's say that we're looking for bad people, okay, and we go out, we're looking for people that are maybe out on social media. We're scraping around there looking for somebody who may be getting ready to do something crazy. Or let's say we already know who we go over and we see a table with terrorists. Okay, and they have their own version of Facebook and all that because they get thrown off of Facebook. And I go over and I start to run inner joins on likes, on profiles. I scrape all that data and I start looking for people. Okay, and eventually I'm going to match something up, and they'll replicate those tables. And goodness gracious, it's unreal. And a lot of times that data is pulled from passport data more than anything. Well, all that being said, okay, and the other is, one of the interesting things is it's always fascinating to me that the people who are terrorists, they're always trying to stay a step ahead of everybody else, but they will always be caught. For example, the folks in ISIS and Al-Qaeda, for the longest time, would buy a temporary phone, okay? And so they'd use a phone, throw it in the trash, and run away. Because if they use that phone and it hit somebody's radar, you may have a drone coming to see you, or a rocket off of a ship off the coast. But what happens is that slowly but surely those agencies go in and they get the ID numbers and they get the coordinates, okay? So they can go after people very, very quickly. And again, this is just, that's an unpleasant example, but, there are a lot of good uses too for this, especially if, for example, if I'm a pharmacist, I'm Walgreens, and I want to make sure I don't have people taking stuff that will kill them if it's put in combination. Now, the pharmacist trusts that the doctor knows what they're doing, but since they have a liability when you and I get medicine, or if you take multiple medications, a lot of older people do, to make sure you don't get an interaction. So the very simplest is we've done just simply an inner join, and we use the alias there for the table just to keep it easy to work with. That's all. Now, what I could have done here is, and I'll end this query off. I'll throw it back off, and I'll show you real quickly. I could do this, select a fruit, and I'm just going to show you. I'm going to give it a column as fruity. Okay, and and we got the number and we got the color. The color as rainbow, and let's see if our little now the reason these are such important chapters is that if we understand the relationships between dimensions that we have and we know the measures, then we're ready to really start to do some data mining and to pull some data together. And I'm going to do that. Let's see what happens. And there it is. Isn't that pretty? I prettied it up by creating a column alias. Okay. And a lot of times people like Amazon, for example, they will give you, you'll see, they use a lot they mask a lot of their tables, names of their tables, so that they don't get hacked. Now, so that's going to be 13.3. Okay, well, we got that done. I do 13.3, and so we've done basically an inner join. Okay, and he talks about the join condition, and he walks off, and the table alias, which is the A dot, and that he talks about that over there. Now, over on page 42, okay, there's a little check your understanding thing, and that's where you're going to be asked to do some matching up there. So you can take a look at that. Let's go over to 13.4, which is over on page 483. Now we move away from a one-to-one relationship to a one-to-many. You say, what do you mean? Let's say I have a table of suppliers, and then I have a fact table of transactions, okay? Well, I'm going to look, and I'm going to have, here's a better one, customers and transactions. This is a lot more intuitive. So, I have a customer that makes multiple purchases. I have a one-to-many relationship with them, okay? And so I want to be able to handle that. So we have one at the bottom there of page 483. And let's pop that there and run it, okay? My apologies about this. I'm a little disjointed after all this finagling, but we're rolling. Okay. All right, now I'm going to go back and I'm going to create. And you'll notice I'm giving us a lot more dialogue, because as we move into the more less rote kinds of things, it's important for us to understand what we're doing. Now, in this case, okay, we're doing a one-to-many relationship. Now, before we run this, let's take a look at it. And hopefully this will help you see it a little bit better. We're going to select A dot fruit, okay, A dot F number, B dot C underscore number, B dot color, and we identify A as the fruits, colors is identified as B, where, okay, the number equals the number, and we're going to order them by the fruit. Now, I'm sorry?
Isn't that the same as the last one? I mean, looking in the book, the sequel looks identical.
Yeah, it does. But if you go over for a moment and take a look at page 484, okay? Jump over there and you'll see the beginning tables, and they do look a lot alike, okay? And you've got the beginning table for fruits, the beginning table for colors, and notice something. When you look at the result table, that's where you get the one-to-many, because you have two different fruits that are red. You see that? Okay, and I apologize. I should have warned everybody to flip over to that page. So I'm going to run that, and here we have apples that are red, right? And we have strawberries that are red, okay? And we have cherries that are red. So that's why we have that one-to-many relationship. The color, okay, is the one, the many is the fruit. Okay, does that make sense? I hope it does. And again, this is where I gave you the example of the customers. So when you look at 484, you see the beginning table, and the authors do a good job of showing us apples, strawberries, okay, and we see that they are red, okay, and they also have a cherry, okay. And we see here that cherries also end up as red as well. And so anything that has a color red, any fruit, it shows up. That help? Makes sense?
Yeah, I realize they're pulling from different tables.
Yes, exactly.
I was looking, I was like,
yeah. You're right, because what kind of throws us is what we call the parent and child relationship between the tables. Now, over on page 44, the beginning table is the parent table. The right-hand side table is traditionally what we call the red the right hand side or the child. And we assume typically that when we do a one to many, that the one will be over in the parent, but sometimes it gets itself reversed. And in this case, it's reversed. The colors serve. The color mimics like the color table mimics a parent table. Okay, and now that's the kind of thing that you could, if the authors had just simply reversed them, it would be a lot more intuitive. And that's really what's going on there. And I hope everybody sees that. And that's why when you're running the thing, it's not always going to be a one-to-many relationship can flow. And if you got your book there, take a look. The table on the left-hand side, we're going to call it the parent. The one on the right-hand side is the child. And typically we assume, okay, that the one-to-many relationship will be from the parent, that is on the left, to the child on the right. But sometimes we have we design tables, all right, and we end up in a situation where we have the many is over in the parent. Okay, so and what would be another example of that? Models of a car. Okay, how many ever models that they have of Ford trucks? Okay, it's trucks, and then over in the you'd have a trucks table to be Ford. Okay, and you'll have all these different models of them. So that's pretty much where we see that type of relationship. And again, it's one to many. Okay, and pardon me, it's a many to one. I'm sorry. Now, and that's where I messed this up. That's a many to one relationship. Now we come to one to many, and that's 13.5. I am so sorry. I need to slow myself down a little bit here. I'm going too fast. All right. Now, if you see 13.5, let's talk about what we've got. We're going to select fruit from table A, fruit number from table A, the color number from table B, and the color from table B, and A is fruits, B is colors. And here we're going to go where the numbers, again, we're using the numbers to match them, and we're going to order them by the fruit, okay? And so we're going to copy that and run that query, okay? And we'll go click create. And we'll run it. Now, when we look at this one, there's some other more germane or more common one-to-many relationships would be a mother to children. A mother would have several children, an actor who plays several roles, a department that has a certain number, many employees, or a customer who has many transactions with us. And so that we have that one-to-many relationship. Now, if you pop over to 486, you're going to see the beginning table and the colors table, and then you'll see the results. And so what we're doing, we've wanted to see where they match up on color. Okay, we're going to match them up on the number. Okay, and we're going to order them by fruit. And in this case, we've got that one-to-many relationship. Earlier it was many to one. I am so sorry. My brain is not working well today. So we've got, and now these three queries we've done, this first one, we're going to save these as 13.4. Okay, and then this one will be 13.5. Now, this is the reason why table construction is so critical because we always eventually have to have some way, okay, to link the tables. And what are we doing here? Well, what we're doing is we're using the number, okay? And that, let's go up for a moment and take a look at these tables we've been drawing from. And we're getting this from the 1304 fruits table. And we'll just go back up here. And we're going to open up those tables. That would be 1304. Okay. All right. All right, here are the culprits. Here's 1303 colors. Okay. And then we've got the 1303 fruits. We've got 1304 colors. And we've got 1304 fruits. And then we have the same thing, 1305 colors, 1305 fruits. Okay. And we'll open those up, take a look at them for a minute. These are, again, what we call slowly changing dimension tables. These are tables that are what we would call legacy tables that they don't change very much. For example, employees, their Social Security number is not going to change. So if you're using it, okay, to run queries on them, you don't have to worry, because you're not going to be updating anybody's Social Security. You may be removing it if they've left or have left all of us, or maybe just you. But we could see this here for the fruits, and then back again for the colors. And we're using numbers, okay, to link these. Now this brings us back to something that's a little bit esoteric, but worth our while to, and I'm going to go ahead and close that. We'll just close them all because we've done. When we do a database, we're performing an exercise in what we call correlated data. And of course, we know the statistical concept of correlation. In machines, when we talk about computers, when we talk about correlated data, we talk about that we actually literally have an address bin. We have a bin in that computer, or a series of bins, a string or something, but space in the computer that we've saved that matches up with space somewhere else in that computer. Okay, and then we harvest the data by running a query, which is a view, and we save the code. We don't alter the table, but literally these are matched up. Now, in the old days, when you did databases, you had to write programming, and you'd use things called pointers to literally tell the address in the computer. Well, today we can do these pseudonyms, and we've got all these little objects that we can play with. So it's much, much better than it used to be. But the whole idea is they are literally at the machine level. They literally match. Okay, and so we have that anchor point. So changing tables or updating legacy tables is a process folks go into very, very wary. Now, over on 13.5, again, we've got that one-to-many relationship. And then on 13.6, let's look at it for a sec. Okay, and we'll open that up. There we go. Someday, and my brain will kick in. Let's go down here to 13.6, okay? Now, we're going to select a fruit, a number, and a color, okay? From fruits, and this is where the number equals the B.C number, and we're going to order it by fruit. This is a many-to-many relationship. And, for example, authors of books, orders and products, cars, and VIN numbers, okay? We have many-to-many relationships. And if you go over to page 488, you're going to see those. You're going to see the two beginning tables. Let's go ahead and copy this and run it, and then take a look and what we're after. You say, okay, I get this. Where do I come in as the decision maker? You should be the one who understands the relationship between the variables. In other words, you ought to understand your business and why people trade with you. What is it that your suppliers want? Okay, because your database should really reflect it ought to reflect the kind of information that you need. Okay, if it doesn't, it's not doing you any good whatsoever. And you never store stuff in a database you're not going to use. You always want to make sure you capture every record, and you only have dimensions, okay, that are meaningful to you. And again, in this case, we're talking about, you know, the fruits and the colors, okay? And so that might be, okay, how many menus, what all do I have on my menus? To give you an idea of a one-to-many relationship, if you go into fast food places, okay, but not a McAllister's, but, you know, a McDonald's or somebody like that, think about the fact that out of their whole menu with all their items, they might have a dozen products that they handle. But because they understand that they can take, and you know, you've got a hamburger, you got a hamburger with this on it, hamburger with that on it, but you got a hamburger, okay? You got buns, you got fries, okay? Different drinks. You know, Sonic, I don't know how many combinations of drinks they have. They play this game out very well. But if you look at a menu for those places, you're going to see products that are staples of that menu. And then they just build around it and embellish, okay? And watch that next time. It'll be an interesting thing as you see it, and you'll go, oh, that's how they do this. And if they're really, really smart, and we're going to save this as 13.6, if they're really smart, they just pare it down and pare it down and pare it down. What they do typically, now one of my favorites is Whataburger, okay? I'm a Whataburger freak from a long way back. And I have to say that. I love Whataburger, but they've got buns, they've got meat, and then they have sauces. And then they got, you know, lettuce and tomatoes and onions, and that's it. But they see all those permutations and they work them out. Okay, so it's like, you know, you go to Brahms and they've got all these different ice creams out there, and you can mix and match, and you know, or you can do a smoothie. That's that whole process now, and those folks don't intuitively see what they're doing, but that notion of one to many, many to one, all of these come into play. And if you understand what about, for example, customers, or you understand about transactions, or both, it really enables you to start to see how things, a profile, or to see how things kind of unfold, and then you understand your business at a much deeper level. Now, we've got 13.6. Let's go ahead and do 13.7, okay? And in this one, we're gonna have a couple of tables, and we're doing the fruit. And you say, golly, we've gotten all these different result sets out of these two tables. Yes, that's because we have an economy here. We're working with fruits, okay, and colors. And you know, whatever my business is, I know what I'm working with. And so we'll run that, okay? And we've got the fruit, the number, the color number, and the color, okay? Because we know we have fruits and color. We're interested in those, all right? You know, if candy bars, you know, who thought there would be 4 different kinds of Milky Ways? I never dreamed of it. Or, you know, 18 different, you look at a candy aisle and it's amazing to me. Reese's, that has about 4 different kinds of Reese's cups. You know, to me, it's, if you're going to have Reese's Buttercups, buy about 6 of them, cram them in your mouth, and then have a diet soda to feel better about yourself. But anyway, we got that task there in 13.7, okay? And here we drop unmatched rows. So you'll notice there, if you look at page 490, you're going to see the fruits table, the colors table, and then the result table, and we drop and get rid of those that don't match. And that way we have an economy of what we got. So that's going to be 13-7. Now, Google, for example, and I'll show you here real quick. Let's just go out and let's do a new tab. And I'm going to do a search for, today was baseball season. Baseball started and I had to work. I have a miserable life, okay? And I looked at the St. Louis Cardinals. See how it filled it in for me? Cardinals, they're Missouri, weather, Blues, Cardinals, all right. Here they are. They've pulled up the score today. The Mets beat them 9-4. So I know when I get home, my wife will be, I won't have to see her. She gets upset and goes into the bathroom during the summer. We watch games. It's sad. I'm a Cardinal fan too, but I've learned to control my emotions to a certain extent. But it filled it in for me, okay, and it dropped off all the other extraneous stuff. You said, what do you mean? Well, first of all, they took me to the scale to the game today, the score, okay, because there was a game. They took me. They popped up another side of the page about the Cardinals, okay, and more images and the score today and all kinds of good stuff. But anything that was extraneous, no way. And look at this, in less than a second, I got, what was it, 30,200,000 results? Woo, that's fast. Well, again, in 13.7, we'll pop this open here. Here we are. And again, we dropped off all the unnecessary stuff. We just carved it out. You can see that in the results table at 13.7 because, again, we're doing some extractive work. 13.8, this is when we've got nulls, okay? And I want to look at this. I want to see this. So we come down here and we're going to work with those where we have any nulls, okay? This is 13.8. And we'll probably make some short work of it. And let's see here. I do appreciate those of you who are here. I know it's the night before heading out, so I appreciate that. Let's do this. It's like the fruit. Okay. Now, anything that has a null, we get rid of it. And if you look over here over on the beginning tables, okay, on page 492, you're going to see that we've got a table that has a null value. You have the kiwi, and there's nothing in there. It's null. And then in the colors table, we don't have a color number. Now, this gives us anomalous data sets, and it also gives us inaccurate results based on what's in the table, which is why, you've heard me preach this over and over. Null values are the scourge of all of us because we don't know if we forgot to put it in there or it's actually a zero. So that's always, so if you run a report at work and you get a bunch of null data, it's probably not a bad idea to say, hey, can somebody look at this? Because I'm seeing all these, they're missing the address, or they're missing the customer number, or they're missing this or that, which is a clue that's telling you, okay, that the data are null, and that's probably about 9% of the time somebody just didn't put the data in. And that's why you recall, as we talked about building tables, and this is all the way back, echoes back to 11:23 if you took it with me, where I preach, never ever collect data you don't need, and never ever create allow a record to be created unless you have all the data. Okay, and that's why you go ahead and put those requirements in there in the table design. So we're going to say this is going to be 13.8. Okay, and the remainder of the chapter is just pretty much more of the same. On 13.8, we see here's the two tables and the result table. Okay, and then over in 13.9, page 493. The author walks us through 5 different ways to write an inner join. Why? He probably got paid by the page, or he just wants to show us that he knows all those things. He's either a very brilliant or very, very sad and lonely person if he's going to spend that much time telling me how to write inner joins. But he wants us to see it, and so he shows us the best solution, okay, and then a variation on that. Now, the variation over there, this is page 494, is just simply we put in the asterisk saying get everything from the table, okay? And then on variation 3, you know, we just use a different, alias for the table. That's all that's going on. And then on variation 4, dot fruit. And we're doing, let's see, what are we doing with that there? We're going to get the section fruit number. There's the number from the fruits. Select and where? Okay. Yeah, that variation 4, what we're doing there is, well, we're just using, we're using the full name, okay, for the table. That's all. And so, and those are the full names. And then finally, variation 5, he says this isn't, you know, recommended, is we select fruit, F number, C number, color from fruits, and then the colors where F dot number equals the F number equals the C number, we order by the fruit. The reason he says it's not recommended is because it's the sparest of the language. It has the less descriptive, it has the least descriptive stuff. Okay. Now, people who are coders or programmers, they operate in that method. But the best one is this one up here he's got on the top. So, you know, we're not going to go through all of those, but I do want to let you see, okay, how we can do some variations with these. 496, 1310. We're going to join the fruits table and the colors table with an inner join. It matches rows where the first 2 columns of each table are equal. This will be fun. Let's try it. Okay, I'm going to go down to 1310. It's a little bit of a change. All righty. Now, notice this. I have 2 numbered columns. Okay. And if you see for the fruits, you'll see the beginning 2 numbers. And then you'll see for the colors 2 numbers. Typically, when we have numbers, they serve as a primary key of sorts, okay? But we can have more than one primary key if we want to, okay? We can have a primary key that is your first name, your last name, your social security number, and your home phone number and your zip code. And if you call into a service center or you call in to talk to someone or something like that, and they walk and they ask you those questions, the reason is they've set their system up so that you have multiple fields, okay, that serve as the primary key, and you can have more than one field that does it. And the whole idea is that when you end up with, you know, when you end up with several keys like that, the probability of somebody accessing your data is astronomically low. Okay, and that's why you anymore if you do passwords, you know, they'll tell you don't do this. You'll get some coaching. You know, don't use consecutive numbers. Blah blah blah. Okay, so we've got the 2 numbers, and really all that's going to happen is we're going to take these 2 beginning tables, okay, and then we're going to match them on the 2 numbers, and that's what happens there in 1310. So let's go ahead and do it, and this allows us. What this does is this gives us a more control, okay, over what we get. I'll get the SQL view. And this is where we really finally tune, F-I-N-E-L-Y, tune the result sets. Okay, now let's see if oh my goodness, great. You people are gluttons for punishment. You're still here. Well, God bless you. Okay. Now, let's take a look there at page 499, and you're going to see we use a join using a greater than condition. Now, look, any of these joins, okay, when I use the where clause, I can use Boolean logic. Look at the if you're there, and I'll open this up. Let's take a look at it. Okay, everybody, and we've got this in this 1311. Now, this is where we're looking for a test score between B beginning score and B ending score. So we used a between, okay, between those two figures. Here we use larger than in 1312, and here in 1313 we use an equivalence. It equals 6. Okay, and he gives you some of the older syntax and then the newer syntax as far as that goes. And on 13.5, here we're matching up department codes again. So he gives us these, we're using these conditions: greater than, lesser than, between, equals, and it's just Boolean algebra. And he walks you through that there on page 500, 501, 502, and I just don't see the need to hammer your heads anymore with that. Now, 1315 starts to bring us to something that's important, and those are lookup tables. And you know, when you took 1123 with me, and even in here in this course, we did some lookup tables where, you know, you remember I go into the design view of a table, and I go down and I run a row source, and I run a query, and then I can get a drop-down menu, okay? And the lookup tables are designed to do that. He says they're called a table of codes, all right? And here he's going to give you an example of that, and that's the lookup table. Many tables, okay, all dimension tables, okay, those that signify types of a variable, or an independent variable. Department is a variable, but it's an independent variable. Okay, we don't measure. They're categories here, so those are slowly changing dimensions. Okay, but we need them in order to create a record. Okay, and then we need them in order to cull through a set of records to get a result set that interests us. And so he talks about those lookup tables, and he walks us through that a table of codes. And if you can run through, and you can see 506, 507. The beginning table is employees. Okay, that's one dimension table. Then then over the top page of 507 is the departments table, and then you have a result table, which is 1315. Okay, so you're going to see a lot of those. And then over page 508, okay, he shows us about the where clause performing two functions. How does it do that? Very simple. It uses a Boolean. It uses an and. Okay, and I'm going to pop over there. And listen, as I do these, all right, when I run a query, don't feel like it's necessary to run every query in here. I think you can. I don't think you really need to do it if you see it and you kind of understand it. If you don't understand something, you know, always send me an email and ask me while we're in here. I'll try to answer it. But I think at this point you're probably growing restless with this because you go, okay, I see it. And then this is just, it's like learning any other language. You kind of get the basics and then you start to tinker with it, okay? And so let's look at this. Well, we have the where clause, all right? And then we have a surprise, the and. So we're creating two conditions where the department code in one table equals the department code in another, and the employee ID is less than 206, and we order it by employee ID, and it will order it in descending order. Okay, and so you can see, basically where you've done. You can see this is where he begins to walk us through. Okay, doing these tables now. At the top of page 509 is step one. Pardon me. Step one, okay, is the bottom of page 508. Okay, and we do this inner join of the tables where the employees, okay, match up where the department, pardon me, where the departments match. Then we do a second piece, and again, we're gonna save this as a view, okay, and then we get that result set, that 1316 view, which we saved up there above in page 509. And what we start to do is we start to see series of joins. And that again is that process I showed you in the text at the start, where I join two tables, get a result set. Then I take that view or result set and join it with another table, okay? And then I get a result set, and I join, and it goes on and on and on, okay, until I've worked through it. Yeah, question?
So it has us doing the two steps, but the thing before with the all-in-one, that would work as well?
Yes. Okay. It should work. It should for, yes. We have everything in all. He's just kind of walking you through the iterations, but where you have everything in there, it should. Now, one of the things that will happen when you go out to work is you're going to be doing this as you're thinking through a problem or working with your dashboard or whatever you're working at at work. Whatever tool you're using in terms of a DB or some dashboard. And a lot of this will be very intuitive to you. And it'll be intuitive because you'll come to understand, okay, the dimensions that you're working with, all right? And you'll come to understand the measures that are associated with them. And then you'll begin to produce fact tables, and you'll be able to take those fact tables and dump them in, or you'll have an engine that will let you do numeric work that'll give you a picture or a profile or something like that. So you're going to be doing this stuff. It'll be intuitive to you, because once you learn the business or you learn the company or your customers or whatever, it will become quite intuitive. It'll become a point where you're not really conscious of what you're doing, okay? And that's fine, because if it's a good database product, it will do that, okay? And if you really know, that's why when we talk about why you've heard me say it before, when I go and work with someone on their database, always ask them, okay, what are the 5 things you need to know? Because I know ultimately that database is where they're going to go get data to pop up on their screen for reports, daily reports, weekly reports, quarterly. What is it that you really need to know, okay? And that way you have what we would call query discipline, where the queries that are run make sense and they're disciplined. Okay, what happens is most people get one of these clients and they're so nice, and they go query happy. They just start saying, well, let's just, what if this and what if that, and that's great, okay, but it's better for you to use it in an intelligent way, and that is to have a set of queries that produce that piece of data or sets of data that you need on your device at your fingertips every single day. and everybody has to have that. Everybody needs that. And and if when I run into people that tell me they don't know, I ask them, okay, well, how do you know you're successful? And they'll tell me, usually it's maybe financial. Well, how do you know or if it's if it's a church, they'll say, well, okay, baptisms this month, or attendance in Sunday school, okay, or attendance in the worship. And and then you're able to kind of walk people back. I'm going to give you an example. I was working with a church, and they were just absolutely they wanted the number of people who attended their service every Sunday. They had 2 services, and they wanted to know the number of people. Okay, so again, in churches, people love the Lord. They're volunteers. Okay, so I'm not in a place to say we're a bunch of idiots. There's no way, because they're doing a lot with a little. And so, and dealing with volunteers, whoo, God bless those people. And so they'd have folks who would count, but they'd stop and gather their numbers up. And then, and this was right, and then they would probably have, and I observed, they'd probably have another 40 or 50 people come in after they took the count. And so I'm going, okay, you need to count this twice. You count at the start of the service, at the end of the service. And the blowback on that was very interesting, because they saw it out. And so I went 3 Sundays in a row, and I counted. The service started at 9:30. They took a count by 9:45. I took a count at 10:15, and they were undercounting their attendance by 30 or 40 people a week. Now, why was that important? Well, because they want to see the turnover rate from people who attend a service, okay, or going to church, who then go to a life group or Sunday school, whatever you might call it, because there's usually a ratio that you can predict that a certain percentage of the worshipers are going to go on and go into Sunday school or church. So you kind of know what you're dealing with. And I've never seen a church in the history of the world, or heard of one, where you have more people in Sunday school than you do church. I guess if you're serving, if Sunday school, you're having a buffet meal for free, you probably would have more people. Knowing Baptists for sure. But the bottom line is, you got to make sure those counts are good. Now, I add that in there just so you kind of see the kind of experiences that you're going to run into. And again, if it's when you're dealing with folks like volunteers, that's one thing, but you always have to be thinking about and be on top of, what is it I need to know? Okay. And that's what we're here. And so we've got this, and let's take a look at 5:11, which is, we're going to do a join now with a summation. Aha. Now we're starting to see, now we're starting to do some aggregation. Now, and bless your hearts, you guys have hung in here for quite a while. I'm gonna finish here in about 10 minutes or so, and we'll do 13. Okay. Now, if you look at query 13.7, what you're going to see is, okay, the fields, and then you see the count. Okay. And that count, that's the count function, okay, with the asterisk saying count as many as there are as the number of lunches from the employees A, the lunches B, where the employee ID equals B, the employee ID, and not 208, because 208, we don't want to count it. Then we group. Then we use a having clause where the count's greater than 1, and we order it by employee ID. Now, I'm just going to go back here for a moment, and I'm going to just selectively highlight this so you see what happens. Now, this is the first piece of this. We're going to get the count as the number of lunches from these 2 tables. Okay? And then we set up the where condition. And we do a where, and a not. So we're honing this down where the employee ID, where the two employee IDs equal and not employee ID of 208. So we're going to exclude 208. And then we do the grouping, and then we use a having clause, and we order it by employee ID. And for 1317, they show you the beginning table. See, there's the query and then the result table there. I don't think they show us the beginning tables, the tables for that. It's all these different tables that are scattered through the chapter. Okay, this is what we're doing here is we're drilling down. We're getting more and more specific about what we want, and in addition, we're aggregating the data. We're counting them. Okay, and that's what that count's all about. And you can see there on the result table for 1317, you see the number of lunches, and so we've done some aggregation. If you look over on page 512, they talk about the Oracle Data Dictionary. Skip that. Then on page 514, he begins a journey of combining 3 or more tables. And you know, if you want to pursue that star in the east, feel free, my friends, do it. But look, here's the deal. He's gonna it's just that iterative process that we talked about before, okay? And creating a join, or pardon me, a view, and then another view, and then another view, okay? And at some point, and that's why he took us over here to 1317, you begin to aggregate everything if you're doing that type of operation. Otherwise, you're doing an extractive, a distilling kind of operation, okay? And that's pretty much chapter 13 all done. Now, let's go ahead and just so that, let's impress ourselves. We'll go ahead and select 1317, okay? And we'll run that query to the SQL. Now, let me say this. Right now, you know more about databases, and you know more about how to build information system, the critical information for your company, than 90% of the people that are going to go out there and look for a job or are out there already. Information is, other than people, is the most important resource a company has. It is. If you don't believe me, go ask somebody who makes pharmaceutical products. I guarantee you they're going to go, oh yeah, very, very important. Okay, I forgot the one, didn't I? Okay, 1317. And there we are. So I'll tell you what you're going to do. I'm going to close this off, okay? And then I've done this, and you want to go ahead, open this back up and make sure I've run all those queries at 13s. There we go. And I'm going to just simply, I'm going to put this as SQL Fun, and I'm going to rename it as Harmon, or you can use, if you want. It's so funny, I have to tell you this. Some of the freshmen that I have in 1123, when I say now, save it as Harmon Keith, are literally saving it using my name. Yeah. I don't know what we've got behind you, but I'm going to be sorry to see all of you leave. That's all I got to say. So yeah, Harmon, and they're just following orders. I understand that. Okay, and then I've got Harmon Keith, and I'll put LD 13, and we're done. Thank you so much, guys. I know it's almost 8 o'clock. We've been at this quite a while. Have a safe weekend, and I'm going to go ahead and shut this thing down, and this will be
Dr. Harmon?
I'll do some more. Yes, question.
Yes, I had a quick question.
Okay.
I believe there's assignments coming up in April, like on April 12th. It says B1, number 1, page 25, T3.
Those are in the business intelligence text.
Okay. Are we going to be doing them as a class, or is that something?
No, just do them. just do the assignments. They have you go over and look at a website or go do a task or something like that. So just do them. Yeah.
Okay.
Yeah, we're not going to do them in class. No, we'll be doing these. Those other ones are just kind of exploratory kinds of things for you to take a look at. Okay?
Great. Thank you.
All right. Anybody else have a question? If not, have a safe holiday weekend. Thank you so much. And sorry about the late start. We're good to go.